my name is Bartosz Blimke, and today I'm going to talk to you about WebMock, a Ruby gem for mocking HTTP requests. So first, a little bit about me. I've been developing software for over 20 years. And back in 2006, when I was still a happy Java developer, a friend of mine, Andrzej Krzywda, came to me and said, "Hey, have you heard of that language getting popular called Ruby?" And he sent me a link to that book. I have seen a few copies yesterday, and my life as a programmer has changed forever, and I've been using Ruby ever since. I live in Warsaw, but I work remotely since before that was popular. And I'm the author and a single maintainer of WebMock. It's not the first year that I'm presenting about WebMock. My previous presentation was back in 2009. That's me, back in London. And I decided to do an extrapolation of my presentations. And I estimate that the next year I'll be presenting about WebMock. It's 2039. So you have a unique chance to learn something about WebMock today. Okay, so what WebMock is for? First, WebMock allows you to stop HTTP requests. But what does it mean? It allows you to declare fake responses so that when your Ruby application makes an HTTP request, a fake response will be returned instead of making a real HTTP connection. And it also allows you to verify that request has been executed, whether that was a stubs request or a real request. The idea is not original. There was a gem called FakeWeb before, but it was not sufficient to my needs. Therefore, I decided to create my own solution. And I created WebMock, the first version, during a one-day company hackathon. And what's important, I created WebMock to address my own needs as a Ruby developer. And these needs happened to be the needs of many other Ruby developers. And hence, WebMock has been downloaded more than 270 million times. It has almost 4,000 stars on GitHub. If you haven't started yet, please do. I'm aiming for 4. Over 260 people contributed to WebMock over the last 15 years. John Gallagher just yesterday. Thank you. Including AI. So a few months ago, Sam Saffron, the co-founder of Discourse, submitted a pull request to WebMock, and he included a transcript of his conversation with ChatGPT. Fortunately, ChatGPT was completely useless in that case, therefore we as human Ruby developers are still safe. WebMock is used by thousands of projects on GitHub, and it's a dependency of thousands of registered Ruby gems. Here are some of the popular Ruby projects that depend on WebMock. And if you haven't had a chance to use any of them, then you probably used this one. WebMock also inspired programmers in other languages who created similar solutions. Okay, so what does WebMock offer? Well, first, it gives us this nice DSL that allows us to write a clean code to stop HTTP requests. And it also gives us nice DSL to verify that requests have been executed. And what's important is that both of these DSLs are HTTP client library agnostic. So once you write it, you can use it with any HTTP client or switch HTTP clients without modifying your tests. WebMock follows stop, execute, verify paradigm, which I borrowed from a Java testing framework called Mockito. And it's slightly different to what, for example, you can get used to with RSpec, with a single expect declaration both creates the stub and creates the expectation. Here these two steps are separated, but it allows us to stub requests without verifying that they have been executed, or verify real requests without stubbing them. WebMock also allows us to run callbacks after each request. And this can be, for example, used for recording requests that have been executed. WebMock offers many features when stubbing, so you can stub your request to timeout, or you can stub requests with basic authentication, or you can even record raw responses with curl, and then declare stubs that will return these raw responses. WebMock supports all popular HTTP clients in Ruby, and it supports all popular testing frameworks. Okay, so we know what are the basic features of WebMock, but you might ask why mocking HTTP requests in the first place, right? So first, it allows you to run your tests in isolation without an internet connection. So if you came here by plane, like me, and you wanted to work on the plane, WebMock is a perfect solution. You can run your tests without actually having access to an external API. It also allows you to avoid accidental changes to third-party APIs. For example, if you incorrectly configure your development or test environment with production credentials, no changes will be made. WebMock will prevent that. WebMock also allows you to run your tests reliably. So even if you have a weak internet connection or a third-party API is currently down, your tests will still run. And the tests are fast, because you're not depending on the current internet connection or on the fact that third-party API is currently busy and the responses are delayed. And you can test all possible scenarios, all edge cases. You can test timeouts. You can test 500, 400 responses. And all this setup is done in Ruby. So there is no need to make some setups remotely on a third-party API. But mocking HTTP can be useful also in other environments than test environments. So, for example, you can develop without having an internet connection. You just need to declare some stubs, put them into a race initializer, if it's a race application, and you can run, you can develop your app without having an internet connection on a plane. You can also manually test your application and test various scenarios. So you can test how your app will behave if a remote API times out or returns 500 response. And you can also develop without actually having access to an external API. So there was a project once that I worked on that heavily relied on a third-party API, and yet we haven't received access to that API for about 1.5 months. So what we have done, we read the specification and documentation of that API, we created some request stubs, put them into race initializer, and we were ready to go. We developed. And you can do the same in staging environments to demo the features that we have implemented. So this is how a sample race initializers with some request stubs can look like. Okay, so we know that mocking HTTP requests can be useful sometimes. But why WebMock? Why would you use WebMock instead of creating your own solution or stubbing maybe HTTP client methods directly? So let's say you have this kind of code in your application and you're expected to change it, to modify the functionality. So what do you do first? Well, we want to do things properly. We want to do things test first. So first we find the corresponding test. So we find the test, and we find that associated, complicated setup. So what do we do first? What I would do is probably I would do git blame and check who wrote that complicated code, just to realize, yeah, it was me a few years ago. And then I would import WebMock and replace that complicated setup with WebMock DSL. And now that I have a clean, readable test, I can modify the code. So for example, I can also change the code to be more readable by replacing NetHTTP with HTTP-RB, which also gives us this nice DSL. WebMock is perfect for test-driven development. Because of WebMock DSL, you can focus on the functionality, on testing the behavior, not the implementation. So you can write your tests first without even deciding what HTTP client you're going to use or what methods on that HTTP client library you're going to call. But WebMock is also very useful for legacy applications. So usually what I will do when I inherit some legacy Ruby application, I will import WebMock. And now I'm safe. I can run my tests. I can run in development without risking that the app is going to make any unexpected requests to a third-party API. And if it does, WebMock will let me know about this. WebMock allows us to stop your unescaped versions of the URLs. So for example, I find this code at the bottom way more readable than the one in the middle. And the feature I really like about WebMock is that if you declare your stub incorrectly, or the stub is actually correct, but the request is incorrect, WebMock will stop the request and will provide you with this nice instructions on how this request is expected to be stopped. So you can just copy and paste it into your test setup. So basically, WebMock exists to make our lives simpler. But with that simplicity, with that DSL, there is a cost, the cost of not knowing what actually happens underneath. And that might feel like magic a bit. And a few months ago, I went to Xavier's presentation where he explained how Sidework works internally. And that got me inspired. And I thought, I'll do the same. I'll explain how WebMock works internally. But in order to understand how WebMock works internally, we first have to understand how HTTP clients work. So let's take a sample HTTP client. The typical client will usually provide an API, which consists of some public methods that usually represent HTTP verbs. But these public methods usually do not do much. So we can use them like that. But yeah, usually they don't do much. There is usually some method or set of methods that do all the heavy lifting underneath. So let's call this, for example, let's call this method handle request. So what this handle request method usually will do is it will first gather all the parameters that you have passed, and it will build the request object. And then it will send the request over HTTP or TCP or SSL connection, and upon receiving the response, it will build the response object. And if the HTTP library client supports middleware, it might also run some middleware. Okay, so now that we understand how typical HTTP client works, we can understand how WebMock works internally. So first, stubbing. So when you do a stub declaration like that, what WebMock will do underneath is it will create a request stub object. And that request stub object will be then registered in the global request stub registry. And request stub object consists of two attributes. So one is request pattern, and request pattern contains all information required to match the request associated with that stub. And then it has a set of fake responses that are expected to be returned when a matching request appears. And what's important is that the stub request method returns the stub itself, which allows us to chain it with some additional calls. So we can call it with the with method. And the with method is to extend the request pattern, so we can add additional criteria to match the request. And again, we are returning request stub object, which allows us to chain it with the toReturn method. And toReturn method adds a fake response to that stub. So when a request will be made matching that request stub, matching the request pattern, this declared fake response will be returned. Request callbacks. What will happen if you call after request? WebMock will take this block and register it in the global request registry. So we now have this global stub registry. We have the request stubs. We have some callbacks, but still nothing happens, right? So if I now make an HTTP request, it won't be affected. And so what actually does the work and intercepts this request is in WebMock are the adapters. So WebMock has an adapter for each HTTP library. So it will be a separate adapter for CURP or separate for NetHTTP. So to understand how an adapter works, let's create a sample adapter for our sample HTTP client. So what an adapter will do, it will create a copy of a class that contains our handle request method that does all the heavy lifting. It will create that copy by subclassing. And then it will start monkey patching that handle request method. So first it will, after the request is built, WebMock will create the request signature. And the request signature contains all necessary information to match the request against the request pattern. And this request signature will be registered in request registry. And then if there is a stub found that matches that request signature, WebMock will return any declared fake responses. Otherwise, a real request will be made. But yeah, WebMock by default prevents all real HTTP requests. So in addition of that, it also has to check whether a real request is allowed. If it's allowed, a real request will be made and a real response will be returned. Otherwise, WebMock will raise an error. And after that error, you will be presented with this nice stubbing instructions. After that, if there are any callbacks registered, WebMock will run them. If there is any middleware supported by the HTTP client, it will be run and then a response will be returned. So to recap, request is built, then we build request signature and register it in the request registry. Then if there is a stub matching that request, we return a fake response. Otherwise, we check whether it's allowed to make a real request, and we make it. If not, we raise an exception, and the nice instructions are printed. The callbacks are run, middleware is run, and then a response is returned. So this is how an adapter works. Okay, but just by creating this copy, this monkey patched copy of a client of this class, still nothing happens, right? If I call sample HTTP client get, still a real class will be used. So we have to do something more. So what WebMock will do, it will first create a reference to that original class, and then it will replace the original class with our modified class, with our monkey patched class, by using constant replacement. So, yeah, and while this solution, might not sound nice because we are doing monkey patching, right? And monkey patching is bad. I quite like it because we are not modifying the original class, we are just modifying the copy. And at any point, we can call WebMock disable and we can revert to the original state. So now when we call WebMock enable, all adapters will be enabled. The created copies of original classes will be created and then originals will be replaced. Now when I call stub request, a request stub will be registered in the request registry. Then when I make the request, a fake response from the stub will be returned. But now we can do something more. So if you remember the request signatures that we registered in the request registry, we can now verify that request can actually be made. Okay. So this is how WebMock works. As you can see, there is no magic. This is just brute monkey patching. And as I told you earlier, I created WebMock to address my own needs as a Ruby developer. But there was also another factor that greatly affected me and greatly influenced me to create WebMock. And that factor was people. So back in 2009, when I created WebMock, I lived in London and I worked for a company called New Bamboo. And New Bamboo was a team of very passionate developers. We inspired each other, we supported each other, we shared our passion for Ruby, we encouraged each other. And during my 20 years of building software, the thing I have learned is that the most important factor for your growth as a developer is the people you work with and what you learn from them. Therefore, when Linus Torvalds said these words, I took it as a compliment. Because to me, Ruby was not only about the nice syntax, not only about Rails. It was always mainly about the people. The people who share their passion. The people who are friendly to each other. The people who inspire each other, like on events like this. And people who are nice to each other. And I am really happy that I can celebrate with all of you our passion for Ruby today. Thank you.